All right, welcome back. So we started with some basic information here in Orange and doing some basic visualizations. There is more. So there is violin plot, there is box plot. You can use them as well. For now, let's continue. And what I want to do is this. So another thing. So you see, you can click on these things and then see what they have and then add those as you find them, necessary, let's say. But another way to add widgets in your workflow here is this. So you don't have to remember everything. You can search for them. So let's say I want to connect something to file. I hold my left mouse button there and then I drag it towards here. And then if you let it go, this will show up. Here you can search. In this case, I want to do a basic hierarchical clustering with this data set. So the first thing I need for that is the distances to be calculated. As I start writing this, there, DIS, and then this distances will come up. So you can select it and voila, it's being entered right there, which is what I wanted. So now if you click on it, you will see distance metrics here. So different distances, distances can be, when you calculate the distance, you should apply a method for it, and these are the different methods for that. Euclidean, cosine distance, Manhattan distance. There is a lot more. You see, you cannot use anything you want, or even if you use it, wouldn't make sense probably. Some of these things are based on the type of data you have. Um, Generally, Euclidean distance is, the best one to go with. It's the most used one, and unless you know exactly what you're doing, probably you will go with Euclidean. But then, of course, like if you have text data, for example, there, this is not going to be useful. Probably Jacquard distance will be more useful there. So you should definitely understand what these distances are when they are used, what they mean. Now, the good thing is you don't need to know exactly how they are calculated. I mean, you can have a general understanding, but that's it. Since everything will be made here, you don't need to know the formulas or anything, but you should know in what kind of situations which ones are used. Euclidean is the most common one, mostly used, very widely used, so we'll stick with that. Um, and next, we'll connect these distances into hierarchical clustering. So let's do that. Let's double click on it. And this is your hierarchical clustering right there. Okay, what does this do? Well, first of all, it uses the word linkage. So you see there's 5 different linkage types here for the hierarchical clustering. Word method is being used. Um, Now, what do these mean? It basically, it starts with each individual point and starts combining them based on how similar they are. So it calculates those distances, and then, each of these methods have their own way as well of combining things to create these clusters. So, this word method is being used. Again, here we're not going to go into details of what they are, how exactly they work. We don't need to. If you're interested, you can search for it and then find it yourself. But the idea is, you see, for example, this point and this point, they are very similar. That's why they are right next to each other and they are being connected. So this is one cluster there. And then another point is being combined to this cluster, so it becomes a larger cluster. Okay, this why are they connected? Because based on all the other points, they are found to be most similar to each other. And as we see, you see these are smaller clusters. They are combined to become larger. They are combined with their neighbor clusters as well. So this method basically starts from small, goes to large. Starts with all these small connections and then combines them to become larger and larger. And you see here with a nice thing, when you look at, for example, this cluster, you can see all of the points are from the blue class. Remember, the blue class was easily like um, what's it called, separated from the others. So you can see that behavior here too. So that's not a because it was quite obvious there. We could even see it in the scatter chart. So that's why we can see it here too. Now there's more here if you scroll down. Like for example, there is this kind of this small red cluster, and then if you look at this, yeah, this is mostly red with a few green. Um, There's a small cluster there, another small one. So this small one is red, this one is green, this one is green, and then it combines them to become a mostly a green cluster over here, and this one down here is definitely a green cluster. Or if you look at this larger one, yeah, there's a bit of overlap. Remember that middle area in that scatter chart? So that's what we are looking at here as well, kind of, if you think about it. So pretty much, right? So that overlap there. So one, um, actually, let me put this down in scatter chart. One nice thing is this find informative projections. So it will look at the different combinations here to show in the scatter chart, and then we'll come up with the best possible two. In this case, best possible two, you see this petal length and petal width. What do we mean by best possible two? Here, the main purpose is the class, the target variable is a categorical type. So we want to do classification. That's our main goal here. So you see it will come up with a scatter chart with the two variables in our data that best kind of can visualize that. And petal length and petal width is good for those. You see the blue class all on its own. Green and red is also very nicely separated with these two variables. So it seems like petal length and petal width are really important in this classification process. There's a bit of overlap here, but even then you can separate them with a line like this. I mean, still there will be error, but you know, it's that error is minimized by doing this. So you see, this behavior here now can be easily seen in that dendrogram as well. See in this dendrogram, yeah, that's where the overlap is mostly. This is the mostly that red class, and this is basically that area of all the blue flowers there. Okay. So yeah, and you know, if you go all the way here, this, you know, at the end, all the data points can be connected together to become one full big cluster. But again, this is not useful. So here we're looking more like three clusters, right? Because we know that we have three classes. So I would say this is one, maybe this is another one, and this one is another one here. Okay. Um, Now, oh, one thing I want to mention here with this clustering method, either k-means clustering, which is very popular, or this hierarchical clustering, doesn't matter. It never uses the output variable. Okay, it never looks at the labels. It never looks at, in this case, to the iris flower types. It doesn't use that. It only uses the input variables. So the sepal length width, petal length, and petal width, those variables are being used to create these clusters. You need to keep that in mind. This coloring is done later on. You see this here? So that labels are being added later to the points because we know which point, is which type. We know that, so we add it afterwards, after this clustering process is complete. And coloring is also based on that. So normally what the clustering is giving us is this. Okay, that's it. But because we know which point, every point basically we have the ID, so we can just look at what type of flower they are, and also we can just color them based on this. So then it looks much nicer, much more understandable for us. But again, the clustering itself, the method itself, is an unsupervised learning method, so it doesn't use the output variable. The target variable is not being used. All right. So this is the final outcome. Now, these are different methods, so the way they kind of create these clusters might be a bit different from each other. The way they measure things in terms of finding that similarity might be a bit different. Um, so one way to assess is looking at these clusters and see which method gives a better cluster to you. Okay, so that's one way to compare them. And again, you can also read on them and then see how they differ from each other. So this clustering method, this weighted, for example, acts a bit weirdly, it seems like, right? Because they've got this blues and here they're separated out with this red in between and so on. Um, yeah, I didn't like this one too much. I think Ward is doing a pretty nice job here. All right then. Well, thank you and see you later. Oh, okay. Wait. Before I close, sorry guys. um, I wanted to show one more thing, and that's this one. So visualize, let's put a scatter plot here. Okay. Now I will connect this hierarchical clustering, and I will connect directly this data, my data, you see. I will connect it to my scatter plot, and I will connect the hierarchical clustering, the output from there to here as well. Now, what am I trying to do? Let's open this one, and I will open this hierarchical clustering as well. Okay, it will, yep, there it is. Okay, so what am I trying to do? Let's say you want to see these points closer. Okay, of course I need to make this smaller now. Okay, so before, okay, wait, let me disconnect this connection. Okay, so we have the distances calculated, we have the hierarchical clustering, and we connect that to a scatter plot output. Good. Oh, please don't go. Okay, I have to, yep. All right, perfect. So let's say I want to analyze these points further. Let's go with smaller ones, so like this. So you see those points now are being shown in my scatter plot. This area now is shown with red and green mostly. This one is red and green. You see those are shown, and these are all the green points. Now, this is very nice, right? You can directly take an output from your clustering method there and then visualize it in your scatter plot. Um, okay, so this is a very nice tool. This is incredibly useful actually, because now I can look in detail, kind of in a different way into the cluster where I use my data set, two of the variables there, and then see how those points look like in this scatter chart there. Okay. Now this is all good, but you see what happens when I select some different area. This x and y changes based on the minimum and maximum values in that among those flowers. You see, it changes based on that. So x and y keeps changing. And also, I'm not seeing any of the other points because only these points that are selected are shown. Now let's make a change there, and this is very useful. It's a very interesting idea. So I will connect this file directly into the scatter plot. Now what happens? The scatter plot has two inputs. One, the whole data set is being used as input. That's this connection. And the other one, the hierarchical clustering output is being used. So what will now happen is that every point will be shown because we have this connection from the file, but only those that are selected from this hierarchical clustering will be highlighted. So it will be even a better um, result for us. So let's open these back up. Okay, so you see, okay, when I select everything, of course, everything is being shown. When I select, okay, it's still behaving as before. Normally all the points should be here and only those selected should be highlighted. Okay, let's go back here. Let's see what's going on. Oh, it's this connection. Let's see, data subset. No, here. Okay, if you want to cut this connection, just click on it and then make a connection from data to data. Because I want this whole data being shown here as well. So data to data, basically, I don't want any subset or anything. And then make this connection after that. So this is selected data and this is data subset. So the selected data will be the data subset in here. Oh, this is beautiful. I will get rid of this label. No, do not show me any labels. You see that? So all the points are shown, but they are empty. Those ones, the ones that are selected, that were selected, they are now highlighted. This is, I think this is incredibly beautiful. So let's find the dendrogram back. So this is called a dendrogram, by the way, for hierarchical clustering, this figure. Let's say I want to see these green flowers. Okay, they're all here. You see that? Or let's say this blue cluster up there. Let's see them. Okay, they are all the blue cluster there. And there's one, you see this flower? This one is also blue. This is kind of an outlier. That's this one right there. The interesting thing here that's also nice, although this flower is within this cluster, you see, it's still close also to this other blue cluster there because of the distance there. You know, it's kind of very close to it's basically in the vicinity of this blue large cluster there. Okay, these points are all mostly red and a few green. These ones are right there. So you can see you can either select larger clusters or, I don't know, these smaller clusters like that. This way you can have a bigger picture in the background, and then the one that you're focusing on is highlighted so you can see them in more detail. Let's add some jitter too. Okay, did this change anything? Okay, I think jittering does not work in this case. All right, because nothing is changing. Yep, jittering is not working in this one. I think it's because of the selection from two connections. Maybe that's why they didn't want to do it there. Okay. All right. So yeah, this is, you see, this is a very nice tool. So this is all the green cluster here. Okay. All right, guys. Well, thank you and see you later.